First, how do you make it into a rectangle? All right. Three different ways. Three different ways you can make any quadrilateral into a rectangle. Two of the ways you got to say it's a parallelogram first. Do we have practice in proving a parallelogram? Yes, last week. All right. So the first thing you got to do is prove it's a parallelogram. Then after you do that, you have two options. Whatever one you're available for, whatever one's available in the proof. Prove it's got one right angle, or prove the diagonals are congruent. Now, let's say you don't want to prove it's a parallelogram. Say, you know what, forget that. All right, I'm too good for that. There is one and only one way you can go right from quadrilateral to rectangle, and that it has four congruent angles. Basically, it's the only way you can prove it's a rectangle without showing it's a parallelogram. And I will tell you, most likely, you're going to prove it's a parallelogram. Okay, unless you want 18 steps to get all four angles congruent. All right, which I'm not reading, by the way. Okay, so bottom line, first thing, let's try to prove it a parallelogram and then see if it's got a right angle or congruent diagonals. Okay. All right, so if you want your highlighters, whatever it is, because A, B, C, D is a parallelogram. If you're borrowing any colored pencils, make sure they get back because most of them end up on the floor instead of on the desk, so make sure they get back. And I also have some perpendicular lines rolling around, huh? D, E, and AB are perpendicular, and so are CF and AB. Do you see the figure I'm trying to have you prove a rectangle? DEFC. DEFC. So I need to show this one is a rectangle. First thing, well, I guess, hey, if you wanted to try to, you already have two right angles. If you wanted to get the other two to be right angles, go ahead. I don't know where that would lead you to, but you can investigate that. Personally, I'd like to prove this a parallelogram first. So can you help me out there? Can you help me prove that that is a parallelogram? Remember, one of the five properties, do they exist? Opposite sides parallel, opposite sides congruent, one pair parallel and congruent. All right, just by knowing that this is a parallelogram, this is where it gets tough now. Okay, this is where it gets tough. Can you help me prove it's a parallelogram? Orion, one thing you want to say? Well, one pair is not going to cut it. You're going to have to show me all the adjacent angles or supplementary. Okay, so you're saying, okay, hold on, stop before we get ahead of ourselves. Everyone agree, DC and AB are parallel, yes? DC and AB, parallel, okay? So DC parallel to AB. Now I'm going to turn it over to you guys. Reason. Here we go, start us off, 12. Why are those two lines parallel? Yep. Got it? And now do you see what Orion was saying where now I can take AB, extend it out to F? So now I can say DC and EF are parallel. That's a great little shortcut right there. Extensions of parallel lines are parallel. Okay, so you got one pair of parallel sides. Now your next choices are the following. Prove those sides are congruent or prove the other pair parallel, and then you have a parallelogram. What can I do? I can either prove these two parallel right here, or I can prove these parallel sides congruent as well. And I'm probably only going to be able to do one. Caitlin, what can I do here? Okay, stop. Anybody know why that's true? Why that is true. Hi, Emma. Okay. How's that get those two parallel? Okay. It is. I'm waiting for the connection to why it makes those parallel. There you go. There you go. Everyone remember, hey, two lines, DE and CF, are both perpendicular to what? Let me say that again. DE and CF are both perpendicular to this AB, the same line, makes them parallel. Yeah, look at those. So now I have DE parallel to CF. Two lines perpendicular to the same line. If I could write correctly. Are parallel to each other. Now do I have a parallelogram? Is DEFC a parallelogram? Yes! 5. I think this board knows the days I do proofs, and it's like, you know what, I'm going to screw around with you. Why is it a parallelogram the way we did this? Why is this beast a parallelogram? 13. Opposite sides parallel implies parallelogram. Okay, it's a parallelogram. Now, how do I make it into a rectangle? One of two ways. Show it's got one right angle, or show diagonals are congruent. I hate to break it to you, but I don't think diagonals being congruent is going to cut it here because there are no diagonals drawn in. But it does have one right angle. You just have to name one of them. Not all of them. One of them. Name one angle inside DEFC that is a right angle. 11. Name one angle. BED. All right, so angle BED is a right angle. Why is it a right angle now? 9. Why is it a right angle? Darn right they do. I don't have to say anything about being congruent. I just need one right angle existing, which it does. So what's this now become? This parallelogram is now a rectangle. Final step, DEFC is a rectangle. All right, so what am I going to put as my reason? And it's, well, it can't be it's got one right angle. There's a ton of things out there that have one right angle. It's not a rectangle. What made it into a rectangle? It was a parallelogram, ready? A parallelogram with what? One right angle implies a rectangle. All right. Get in the habit of showing it's a parallelogram first, and then either congruent diagonals or one right angle to make it into a rectangle. Guys, I can almost guarantee you're never going to be able to do 4 right angles. All right, in a statements reasons proof. Never. Questions? All right, let's get away from the statements reasons for a bit, and let's go on to the graph. Some of you may or may not like this better than the statements reasons because it gives you a lot more flexibility and creativity when it's on the graph. Some of you may not like it because you have to remember all those darn formulas now. Slope, distance, midpoint. It's up to you. All graphed so we can talk? Okay, I love and hate these. I love and hate these. I love these type because it gives you guys so much flexibility and creativity to do whatever you feel most comfortable doing. I hate them because you got to be organized. And I know some of you, this is your idea of being organized. All right, stuff all over the place. All right, I get nervous with that. All right. All right, we have to prove it's a rectangle. So again, let's go over our three options. Let's make a class decision, and at the end, we'll go over all the other ways too we could have done this. We can show it has 4 right angles right off the bat. Very hard to do in statements reasons, but not bad on a graph. We could show it's a parallelogram with a right angle or a parallelogram with congruent diagonals. It's your call. What do we want to do as a class here? We want to go right to saying it's a rectangle by saying it's got 4 right angles. Is that what we're going to do? Or does anybody, we have more people that want to go the parallelogram route? Okay, where's the 4 right angles? How many want to go all 4 right angles right now? How many want to go a parallelogram route? Okay, and then the rest of us obviously don't really care. Huh? Okay. All right, if we're going, I'll make a deal. We'll go all 4 right angles now, but when we get to the rhombus question at the end of class today, we have to do a parallelogram in the middle. Okay? So we'll go all 4 right angles, which means, okay, here we go. It means what formula am I going to need? Slope formula. Yes, I'm going to need the slope formula. So what I need you to write, you guys to do, and we're going to keep all of this organized. All right? You don't need statements, reasons, but I need at least, all right, here's number 1. Here's what I'm about to do. Slope. So I need to see, what's the letter for slope again? M. So I need groups now to find the slope of QR. I need you to find the slope of, let's see, all of them, RS, slope of QP, and the slope of, what am I missing, PS. And because it's on the graph, guys, hey, use rise over run. You know, you don't have to do y2 minus y1 over x2 minus x1. Just do rise over run. Up and over how many? So in your group right now, go ahead. You got a minute. Find the slope of each pair there, or each of the 4 lines. Up and over, and then see which direction it's going, because some of these are in a negative slope. Okay, here we go. Ready? Any group want to give me QR slope? If they're wrong, I guess we can boo them, right? QR slope. Hi, Colin. Negative 2/3. Don't sound so enthused. Negative 2/3. We all good there? QR negative 2/3 because it's going downhill. RS. I think you got 6 over 4. Yeah? Okay. And if you reduce that, that reduces to 3/2. Probably want to reduce it. I'll show you why in a second. What about QP slope? 6 over 4 reduces down to 3/2. And what about PS? Negative 2/3. All right. Here's what I always require. After you perform a formula, next step, tell me what you learned. What did you learn by doing the slope formula right now? You didn't learn they had right angles yet. What did you just learn? What did you learn about QR and QP? They're perpendicular. So here we go. QR, I'm going to list out all the perpendicular lines here. QR perpendicular to QP. Let's keep listing them. If you guys want to do it this way, this is the way it's got to be done. QR perpendicular to QP. QR also perpendicular to QR and RS. What's another set? RS perpendicular to PS, and then the final pair, PS perpendicular to QP. And then obviously you're going to have to tell me a Y now, because how do you know these are all perpendicular? You did all the work. Because slopes are, what do we call those? Negative reciprocals. Okay, so after you show me a formula, the next step should be, hey, here's what I just learned. The lines are perpendicular. The segments are congruent. The segments are parallel. All right, now start treating this kind of like a statement's reasons. Now where would you go from here? You got perpendicular lines. Now what am I going to say? If the lines are perpendicular, you have right angles. So ready? Angle Q, angle R, angle S, and angle P are right angles because perpendicular lines form right angles. We're just taking it out of the statements reasons format. And then now if you have all four right angles, what do I have here? I don't need to say they're congruent. You can go right to saying if you have four right angles, this is A. So PQRS is a rectangle. Because all four angles are right angles. I'm okay with that. I'm all right with that. All right, PQRS is a rectangle because all four angles are right angles. Or it's a quadrilateral with four right angles. We all good there? Because I'm going to have you do it another way when we get to the rhombus. All right, this next one here, we got a beast coming up. Put on your honors shoes. Guys, got any questions about this? And hey, whoa, before we move on. Organized? You're darn right. All right, hey, I don't need one up here, two down here, three way over here. Keep it organized, please. Again, after you do a formula, what did you learn from it? And then you can treat it like a statements reasons proof from there. All right, what about a rhombus? Well, you see four ways to prove a rhombus. Three of them, you have to prove it a what first? Parallelogram first, all right, with some extras. The only way you can prove it without proving a parallelogram is say it's got four congruent sides. I don't know how easy that'll be. Maybe it might be, I don't know, but you have to show all four sides are congruent to each other. Most likely you're going to show it's a parallelogram. So we have duet here, quadrilateral duet, a lot of things going on here. You got D and E congruent. You also have 1 and 2 congruent. And you also have 1 and 4 congruent. Okay. Show me this is a rhombus. Can you show me it's a parallelogram first? Forget rhombus. Show me it's a parallelogram first. Is there any sides? You can show parallel, congruent, Anything I can do here? Sinead, what do you got back there? Okay, don't say why. DT, she's telling me DT is parallel to UE. That is a correct statement. DT congruent to UE. Why? Why are those two? Sorry, you said parallel, didn't you? Yeah, comment down. Good. Why? Oh, 21. Why are they parallel? Oh, look at Vincent back there. Yes. Yes, 1 and 2 are alternate interior. They're congruent. That makes the lines parallel. All right, we're almost making it into a parallelogram. Now you guys can prove these two up top parallel, or you can prove these two parallel sides congruent. And then we have a parallelogram. Which way can we do here? A lot of congruent angles going on. I can either prove the sides congruent there or the opposite pair parallel. What can I do? Dig deep here, dig deep. I don't want to give it to you. Can I prove these sides congruent? Can I prove these sides parallel? See anything here? What's up, Grace? Okay, but that would only make these two sides congruent. Wouldn't make those two congruent, though. Because remember, the two congruent angles need to be in the same triangle, right? Not in opposite triangles. What do you got back there? Only if it is a rhombus. We're proving it's a rhombus, right? The only thing we know right now is it's a quadrilateral. So I really have no properties. Oh, stumped, huh? Yes, Maggie? How? But wouldn't that be 4 and 3? I would need 4 and 3 congruent. Right? If you're trying to prove these two lines congruent, are being parallel. 1 and 2? 1 and 2 are for these here. See? Yeah, sure. But now 1 and 2 aren't a part of those. Look, take a look. Here, let me highlight them. Here's angle 1. Here's angle 2. They have nothing to do with those lines. Right? I'm showing you here. I'm trying to show you why you can't have 1 and 2 being congruent, making these lines parallel. The 1 and 2 aren't alternate interior for those lines. It's alternate interior for DT and EU. Whew. What's going on here, guys, huh? Stumped? Oh, boy. Teddy, sure. Hey, anybody remember proving triangles congruent? How about we prove those two triangles congruent? And then these two sides are corresponding, which would make them congruent. So, yep, let's say TU congruent to itself. Reflexive. Hey, do we have enough to say they're congruent now? Yeah. So triangle DTU congruent to triangle EUT. Okay, then what method? Don't say anything. Three, what method? Angle, angle, side. That reflexive side is not in between, so. Why did I want the triangle? So I could say CP, CTC, what two sides now? DT and EU by CP, CTC. I'm listening, Meg, as I write.
Could you find with CP, CTC, could you find 3 is equal to 1 or 4?
Well, it wouldn't be equal to 1 because I'm just not flipping this over. And we already know 1 and 4 wouldn't be equal because they're in the same triangle. You mean 1 and 2? They're already congruent.
No, but if you get 3 congruent to everything else, then you can make an isosceles triangle and prove all the sides congruent. So you wouldn't have to make a parallelogram.
All the sides congruent? But how are you getting 3 and 4 congruent without proving the triangles here? Well, I know that, but the triangle's got to be congruent to say that. That's what we're doing now. Okay, but all right, hold on. I know what you're saying, but you're using 2 different triangles. Okay, now I see what you're saying. You want to say 3 and 4 is CP-CTC, right? Okay, but that doesn't make all 4 sides congruent because the in a triangle only works for in a single triangle. See what I mean? Like here, ready? Watch. I could get those 2 and those 2, but not all 4.
Because the isosceles sides
Yeah.
that you're proving isosceles congruent, they're the outside of the rhombus.
So watch, ready? Here. See what I mean? Now, if you did a couple substitutions after that, maybe we'd be on the right track. All right? But it might just be easier to prove it a parallelogram here. Okay? So do I have a parallelogram right now? Do I have a parallelogram right now? Why? Because one pair is congruent and parallel. So duet is a parallelogram. And the reason, God, it's killing me. One pair of opposite sides. What do I know about the one pair of opposite sides? Congruent and parallel. Implies a parallelogram. All right, now I want to turn it into a rhombus now. Okay, let's go back up and look. What are the ways I can turn it into a rhombus? I can say it has 2 consecutive sides congruent. I could say the diagonals are perpendicular. Well, why can't I throw out that one? Well, there are. There's one of them. There's not 2 of them, but yeah, there is just one diagonal, and that's not going to cut it. Or I could show the diagonal bisects the angle. One diagonal bisects an angle it's drawn to. All right, so let me just regroup here with everything we had. We got 1 congruent to 2. We got 1 congruent to 4, and you have those opposite angles. Now, I know some of you want to probably go right to saying maybe the diagonal bisects the angles. You could do that with a bunch of substitutions, but there's a quicker way. Is there a way you could show me this parallelogram now has 2 consecutive sides congruent? Maggie? How can I show 2 consecutive sides up here are congruent? Little hint. What do you know in that triangle? It's got 2 congruent angles, right? What's across from them? And what do you notice about those congruent sides? They're consecutive, 2 in a row. Everyone see that? All right, 2 consecutive sides in a parallelogram make it into a rhombus. So what are those 2 sides? DT and DU. In a triangle, congruent sides across from congruent angles. And then duet now is a rhombus. What do you think here, based on what we just did for the rectangle? Because you can't just put in 2 consecutive sides congruent. There's a lot of figures I could show you to have 2 consecutive sides congruent. It's not a rhombus. Go ahead, Vincent. You're the detail one here. Yep. Gotta say it's a parallelogram with 2 consecutive sides congruent. Implies a parallelogram. Questions? Rhombus, parallelogram, yep, good. Good, now it's not gonna let me erase my mistake, so it's just telling me. There you go, thank you. And one more coordinate one. All right, and I'm gonna let you guys are in honors, so you do get some perks every once in a while. I'm not gonna force you to prove this is a parallelogram on this one. Okay. What's the other way without showing it's a parallelogram, how could I show this figure's a rhombus? Show all sides are what? Congruent. Okay, if you're gonna do that, you're gonna have to mess around with the what formula? Distance. And I don't know how some of you feel about that. Okay, so yes, you could do distance formula 4 times. Show me it's a rhombus. Yes or right? You could, but it's got to be a parallelogram first, right? Diagonals being perpendicular don't make it into a rhombus automatically. It's got to be a parallelogram with diagonals perpendicular, okay? The only way you could say it's not a parallelogram and go right to a rhombus is saying that all 4 sides are congruent. That's the only way. All right, if you want to use one of the other properties, you do have to tell me it's a parallelogram first. So are many people going just distance here? Or do we want to go parallelogram? Distance, okay. You could, again, guys, you could also prove it's a parallelogram with perpendicular diagonals. You could also do a parallelogram with 2 consecutive sides congruent, right? But you guys don't want to mention a parallelogram, so we'll go right to distance of all 4 sides. DC, distance of CB, distance of BA, and the distance of DA. You can use the formula. You can use Pythagorean theorem on the graph. Up to you. And I know some of you are clever. You do have to show me the numbers you're plugging into each. Somebody gets radical 8 on the first one, and they just write radical 8, radical 8, radical 8, because they know it should all be equal. That's not how we roll in here. Okay, you show me all the work inside that radical, please, that leads you to your final answer. Hopefully we're all coming out with what distance here? 5, not square root of 5, just 5. Still can't tell me it's a rhombus. Again, remember what I'm asking. If you use a formula, next step, what did you just learn? You didn't learn that it was a rhombus. You learned what about DC, CB, BA, and DA? They're all congruent to each other. DC congruent to CB, congruent to BA, congruent to DA, and then, of course, a Y. Because, why are they all congruent? What'd you just do above? Distances are equal. And now what do you know about this figure if all 4 sides are congruent? It is a rhombus. Why is it a rhombus? Because all 4 sides are congruent. What I would do, I would pick a way. So if it says prove a rectangle or prove a rhombus, you have one and only one way you're going to do it. Okay, and be comfortable with that way. Okay, be comfortable with that way. Because I think tonight what you're going to have is prove it's a rhombus, but not a rectangle. So quickly, we have 30 seconds here. Let's talk. What if I now said prove it's not a rectangle? Where would you go from here? You proved it's a rhombus. Beautiful. How would you prove it not a rectangle now? Prove one of the angles is not a right angle. What formula would I need for that? Slope formula, showing they're not negative reciprocals.